Hi everyone, it's Japoo, and today we're going to be talking about slope fields. Just a reminder, if you would like to follow along to this video, the worksheet that I'm about to do as well as its answer key are linked in the description below. So for the first three problems, we're going to actually sketch a slope field based on the differential equation that we are given. So as you can see, the problem gives us a set of points, and for each of those points we're going to find the slope and then draw a line segment to indicate what the slope is at each of those points. So basically it's a field of slopes, which is why slope fields have the name slope fields. So to find the slope of each point, we have to plug in the x and y coordinate into the differential equation. And then the answer that we get is going to be our slope for that point. So as you can see in number 1, we only have a y value that we can plug in. So this, the slope of these points are based on its y value, and so we only have to plug in the y value for each point. So as you can see, I've already started writing on the right side the points and then the slope at each point. So as you can see, we kind of have a trend in this case since the slope is solely based on the y coordinate. So when the y coordinate is equal to 0 at point 0, 0, 1, 0, and 2, 0, the slope is 0 because we plug in 0 for y in the equation, and 2 times 0 is equal to 0. For the points 0, 1, 1, 1, and 2, 1, since the y coordinate is equal to 1, we plug in 1 for y, and 2 times 1 is 2, so the slope for those 3 points is 2. For 0, 2, 1, 2, and 2, 2, we plug in a 2, since the y-coordinate is 2 for all of those sets of points, and we get 4 for our slope, since 2 times 2 is 4. Now we actually have to physically draw a line segment that represents the slope that we found at each point. The slopes don't have to be perfect, and I would really recommend writing the slopes either to the side or right next to the point itself when you're doing these on an AP exam or a test or something like that, just to indicate that you know what the slope is equal to, and even if your line isn't perfectly reflecting that slope, you still know what the answer should be. Like, you don't have to whip out a protractor or anything and try and measure it, because in all honesty, the grader isn't going to do that. They're just going to kind of look at it and see if it's relatively correct and then move on. But I would recommend writing the slope next to each point just to indicate that you know what the slope is supposed to be in case your line segment isn't absolutely clear. There's two things that you should make sure are clear are if the slope equals 0, make sure that you very clearly draw a horizontal line. That is something you can do very easily. So make sure that you draw a horizontal line if the slope is equal to 0. The second thing that you want to make sure of is that your slope is sloping, I guess, the right way. So if it's a positive slope, make sure that it's looking like this, I think, or like kind of like this way. And if it's a negative slope, make sure it's sloping this way, right? So like that, I think. So make sure that your slopes are sloping the correct way based on whether they're positive or negative. So those are two things that you can do to make sure that your slope is as correct as possible. So as you can see here, right now I'm drawing the horizontal lines for the points where slope is equal to 0. And then I'm going to go ahead and draw the lines for where slope is equal to 2 and where the slope is equal to 4. I tried to make my lines at m equals 4, where the slope is 4, a little bit steeper than the lines that have a slope of 2. But again, it's probably a great idea to write it. Make sure that you indicate what your slope is going to be, just so it's clear. So this next equation is based on x and y, so we're plugging in the x and y coordinates for each point to get a slope. So if we plug in 0 for x and 0 for y for 0, 0, we're going to get n equals 0. If we plug in 1 for x and 0 for y, the slope is going to be 2. If we plug in 2 for x and 0 for y, the slope is going to be 4. If we plug in 0 for x and 1 for y, the slope is going to equal 1. 1 for x and 1 for y, the slope is equal to 3. X equals 2 and y equals 1, slope is 5. If we plug in 0 for x and 2 for y, then our slope is going to equal 2. And if we plug in 1 for x and 2 for y, our slope is going to equal 4. 2 for x and 2 for y, our slope is going to equal 6. So all of our lines are going to be positive sloping, so they're all going to go the same way, and only the slope of the point 0, 0 is horizontal. So again, I tried to draw my slopes relative to each other, so like I tried to make m equals 6 steeper than m equals 1. But I really do recommend that you, again, write the slopes out so the grader knows what you're trying to write. So the one thing that I wanted to mention here, if you look at the slopes that I found already, take a minute, plug in your numbers and stuff like that. You can see that this line is based on both y and x. And since x is in the denominator, all the points where x is equal to 0, so all of the points on the y-axis, have a slope that does not exist. So usually, problems don't really ask you about a vertical line. Usually you won't get m equals do not exist. In this one you do, but it's very rare that you'll see that. So, but I did draw those lines vertically on the x-axis. You can kind of, or vertically on the y-axis. You can kind of see that. And then I tried to draw my lines. They're all positive slopes, so they're all going in the same direction. And I just tried to kind of draw them like relative to each other, the steepness or whatever. So that's sort of what they look like. 1, 0, and 2, 0 are horizontal lines. Also, I want to point that out. Slope fields are pretty easy. They're just kind of annoying because you have to keep plugging in to find the slope at every single point. But this is one of the only things that you're going to draw on the AP exam. Most of the problems that you're asked on the AP exam are like just math problems. You don't really have to draw diagrams or anything, but this is one of the only things that you're going to have to draw. Moving on to the next page. The first thing, well, these questions are talking about the slope field for a differential equation. So in this case, we're actually given the slope field, and we have to find the differential equation that that slope field is based off of. I like to approach these problems through the process of elimination. So basically, I'm going to choose 3 wrong answers, and once I figure out that those are wrong and not the right answer, I'm going to finally end up with my right answer. So first, I have 2 main strategies for this. First, I want to find where the slope is equal to 0. So in this case, the slope is equal to 0 in where there's a column of m equals 0 slopes. We already know that when m equals 0, the line segment that represents the slope of m equals 0 is just a horizontal line, right? So this column right here of horizontal lines is where the slope is equal to 0. So when x equals 1, the slope is equal to 0. So wherever you see a column or a row, well, if you see a column of horizontal lines, the slope will equal 0 where x equals that number. If you see a row of horizontal lines, the slope equals 0 when y is equal to that number. The other thing that I like to use, the other strategy that I like to use when deciding which equations to eliminate to find the correct differential equation is to see whether the slope depends on x, y, or both. So to do that, we have to look at just like a random column. So you can pick any column or row. If the equation only depends on x, the slope is same along each column. If the equation depends on only y, then the slope is the same for each row. So if you look at the column in the row that I just circled, you can see that the slope for each of these lines changes as we go down the column, right? Like these are all different slopes. And if we look at the row, we can see that the slope for all of these lines changes as we go along the row. So that means that our equation in this case is going to have to depend on both x and y. So let's go to number A. First, I'm going to use my slope is equal to 0 when x is equal to 1 theory. So in this case, if I plug in 1 for x, I just get y. And since y is not equal to 0, then that means that this equation is not the correct differential equation. So we can eliminate that one. So it's not number A. If I plug in y for x in B, I get dy over dx equals 2y. That's also not equal to 0, so we know that that is not the correct equation either. I'm going to go to D really fast, and I can just go ahead and eliminate D because the equation only has an x in it, which means that it only depends on x. We know that our equation needs to depend on both x and y, so we know that D isn't the answer. That means that C is the answer. And we can also check this by noticing that it depends on both x and y, because it has both x and y in the differential equation. And if we plug in 1 for x, we get y minus y, which is equal to 0. So when x is equal to 1, the slope is equal to 0. So C is the correct answer for number 4. Moving on to, let me move myself up here, maybe that's going to be easier. Moving on to number 5, in this case, the two strategies don't really help us a lot. So what we're actually going to do in this case is generalize whether the quadrants are positive or negative. And we do that based on the slope. So we can see in the first quadrant, which is this quadrant right here, all of the slopes are slanting this way. That means that the slopes are generally positive. In the second quadrant, we see that all of the slopes are slanting the other way. That means they're generally negative. The same thing in quadrant 3, all of the slopes are slanting this way. That means that they're generally negative. And in quadrant 4, all the slopes are going this way, as you can see. So they're generally positive. Now we're going to look at our 4 options, and we're going to decide whether each of these quadrants are positive or negative based on the differential equation. And whichever small axis matches our graph is going to be our correct answer. So I just like to pick a random point, like maybe in each quadrant. So like 1, 1, negative 1, 1, negative 1, negative 1, and 1 and negative 1. And just kind of see where things are positive and where things are negative. So for the first quadrant, if we have 1, 1, we know that 1 cubed over 1 is going to be positive. In the second quadrant, if we have negative 1 cubed over 1, that's going to be negative. Or that's the second quadrant, sorry. In the second quadrant, If we have negative 1 cubed over 1, that's negative. In the fourth quadrant, if we have negative 1 cubed over negative 1, we're going to have a positive number. So that means that this axis can't be the right answer because it already breaks our generalization of the original graph. Moving on to the next one, 1 squared over 1 cubed is 1. However, negative 1 squared over 1 cubed is going to be positive because negative 1 squared is positive. So this one also breaks. If we do number 3, if we plug in 1 over 1 squared, that's positive. Negative 1 over 1 squared, that's negative. Negative 1 over negative 1 squared, that's also negative, right? And then 1 over negative 1 squared is positive. So that follows our original graph. But let's just go ahead and do D just in case. And since D is x squared over y squared, we know that it's always going to be positive for all 4 quadrants because anytime we get a negative 1, it's just going to become positive. So C is our correct answer in this case. Let's move on to number 6. So if we look closely at number 6, we can see that there's just a bunch of lines going completely diagonal right here. We also see that there's a bunch of horizontal lines going diagonally right here. That means that when y is equal to x, we get a slope of 0. So we already know that A cannot be the answer because y is never equal to x in that case. And we know that C isn't the answer because if dy over dx is equal to 0, y would equal a negative x. So now we're stuck between B and D. To decide whether it's B or D, what we're going to do is generalize about the slope of this fourth quadrant. Since all of the line segments in the fourth quadrant are sloping in the negative direction, we're going to assume that the general slope for that quadrant is negative. That means that when we plug in, let's say, a positive 1 for x and a negative 1 for y, we're going to get a negative number. You can use any point in the fourth quadrant. I just like to stick with 1 and negative 1 because they're the easiest numbers to work with. So if we look at B, we would get negative 1 minus 1 is equal to negative 2. That's a negative slope. If we look at D, we're going to get 1 minus negative 1, which is a positive 2. That's a positive slope. Since we're looking for a negative slope for the fourth quadrant, we know that D cannot be our answer, and therefore we get 2 as our answer. Moving on to number 7, we're going to match the slope field for the differential equation. I went ahead and factored this equation, and we can see that when I factor it, I get x minus 1 times x plus 1. So when x is equal to negative 1 or positive 1, we get a slope of 0. So we can see that A cannot be the correct answer since the slope is only 0 where y equals 1 and y equals a negative 1. Further, if we look at each row, we can see that the slope is the same for each line segment, for each point. That means that this slope field's differential equation only depends on y. Our differential equation only depends on x, so A still cannot be the answer. Moving on to B, or hold on, we're going to go to C first. We see that we do have a slope equal to 0 at x equals 1. And if we look at each column, we see that the slope is the same for each point. However, we don't have a slope equaling 0 at x equals -1, right? So C cannot be our answer. Moving on, if we look at B, we see that the slope is equal to 0 at x equals 1 and x equals -1. However, D also has a slope equaling 0 at x equals -1 and x equals 1. So now we have to figure out whether the slope field for which slope field's tangential equation, or which slope field's differential equation depends on x. Okay. Which slope field's differential equation only depends on x. Okay, I got it out. If we look at D, we can see that since the slope is changing for each point in the column, the differential equation of D depends on x and y. If we look at a column in x, we can see that the slope is the same for each point in a column. That means that the slope of the line only depends on x. And therefore, B is our correct answer because our original equation only has x in it. Moving on to our last page, number 8. Basically, we're just going to have to kind of trace the function to figure out what it looks like, and then pick our equation based on that. Notice that our answer choices aren't dx over dy equals something. They're not the slope equals something, but y equals something. So what we're first going to do is plot our initial condition. Our initial condition in this case is 0, 1. So we're going to plot that point. And then we're just going to follow the lines. So following the lines gives us this kind of shape. Oh, I went too fast. This kind of shape. Okay? The third step that we're going to do is we're just going to look at the shape. And it looks like this, right? I forgot to hit pause. Okay. This is what our shape looks like. Let me move my hand. Okay, this is what our shape looks like. So if we look at our answer choices, we see that we have tan x plus 1. This is what a tangent line looks like. We have x squared. This isn't a parabola. We have x cubed over 3. That's not what this looks like. Well, it does look like that, but see how our initial condition is at 0, 1, and it's not at 0? So if our initial condition was at 0, 0, then we could choose C. But since it's at 0, 1, we know that our answer is going to be D, since that plus 1 at the end makes the initial condition 0, 1. So D is the correct answer in that case. Number 9 is very similar process. We do the exact same thing. First, we're going to plot the initial point, and then we're just going to trace that shape. So this is what that shape looks like. It's kind of like an upside down parabola, but pointy at the top. There's like a point. So we know what the graph of cosine looks like. The graph of cosine has to be underneath the x-axis at some point. And since this one isn't, we know that A isn't the correct answer. B is an upside down parabola. And our shape kind of looks like an upside down parabola, except it has a plateau at the top. So we know that that can't be the right answer. Or sorry, it doesn't have a plateau at the top. So we know that that can be our correct answer. C is a semicircle equation, so we know that that can't be the correct answer. So D has to be our correct answer. So that's also just kind of a process of elimination. So slope fields aren't the most important topic on the AP exam or the most important topic in calculus, but they could score you a couple of extra points on your tests and quizzes. So it is good to know them just to kind of boost your grade a little bit if you want. If you enjoyed this video at all, please give it a like and subscribe to our channel to watch more calculus videos like these. Thank you.